Hello, my name is Professor Hudson. Let's continue with our narrated lecture on Chapter 2, Atoms, Molecules, and Life. This narrated lecture is covering Section 2.3, Why is Water so important to life? Why is water so important to life? Water is critical to life. Some important properties of water include water molecules are cohesive and adhesive. Water is a good solvent. Water has a high heat of vaporization. Water has a high heat capacity. Water forms a solid that is less dense than when it's in its liquid form. Water interacts differently with hydrophilic and hydrophobic substances. Let's take a closer look at some of these properties. Water molecules are cohesive and adhesive. Water molecules are cohesive. This means they stick to each other. This produces surface tension. They are also adhesive. This means they stick to other surfaces. These properties help water move up a tree. It also causes water to form a type of skin that certain insects and small organisms can use for walking. Water is a good solvent. Water can dissolve polar substances such as salt. When a substance dissolves in water, it makes a solution. Water has a high heat of vaporization and high heat capacity. It takes a lot of energy to evaporate water. The high heat of vaporization is the amount of heat needed to cause a substance such as water to evaporate. That is, change from a liquid to a vapor or gas. Evaporating water uses up heat from its surroundings, cooling the nearby environment. This is what happens when we sweat. Because the human body is mostly water, a sunbather can absorb a lot of heat energy without sending his or her temperature soaring. This property is called high heat capacity. It takes a lot of heat to change the temperature of water. It requires 1 calorie of energy to raise the temperature of 1 gram of water 1 degree Celsius. This is a very slow process. Water's high heat of vaporization and water's high specific heat are important properties of water for life. Water forms a solid that is less dense than when it's in its liquid form. Most substances become denser or more compact when they turn into a solid. Ice is unusual because ice as a solid is actually less dense than water in its liquid form. When water freezes, water molecules spread apart slightly. This property of water, the fact that water as a solid becomes lighter, actually allows ice to float on top of rivers and lakes and streams. Water forms a solid that is less dense than when it's in its liquid form. Therefore, when the water freezes and the ice rises to the surface, the organisms and wildlife underneath can continue to live and swim and survive. Water interacts differently with hydrophilic and hydrophobic substances. Hydrophobic substances do not mix with water. Fat and oil are examples of hydrophobic substances that do not mix with water. Hydrophilic substances do mix with water. An example of a hydrophilic substance is salt. Let's review. Please write the letter that corresponds to the correct answer to this question on a sheet of paper, as you will enter this letter in Blackboard's PowerPoint lecture quiz for this chapter. Aquatic living things are able to survive the winter thanks to which property of water? Choose the correct answer. Section 2.3 continued. Why is water so important to life? Water-based molecules can be acidic, basic, or neutral. A small fraction of water molecules can break apart into ions. Water can break down into hydroxide ions with a negative charge and hydrogen ions with a positive charge. Solutions in which the number of hydrogen ions are greater than the hydroxide ions are considered acids. Lemon juice and vinegar are examples of acids. Solutions in which the number of hydroxide ions are greater than the number of hydrogens are basic. Examples of basic items would be baking soda, chlorine, bleach, and ammonia. When we talk about how acidic or basic a solution is, we use the pH scale. The pH scale runs from 0 to 14, with 7 being neutral. Anything less than 7 is considered an acid, and anything greater than 7 is considered a base. This figure is showing an example of some everyday items and where they would fall on the pH scale. For example, the gastric juices in your stomach are extremely acidic. They're in the pH range of 1 to 2. The gastric juices in your stomach have to be acidic in order to break down the foods that you eat. Can you think of a condition where the acid levels in the stomach get out of control and cause damage to the stomach lining? If you said ulcers, you are correct. Ulcers occur when the concentration of stomach acid gets to the point where it eats through the lining of the stomach. Normally, mucus would protect your stomach from the acid, but sometimes this does not occur. If you wanted to neutralize the stomach acid to help reduce the stomach upset you feel when the levels get to be too high, what would you take? That's right, most people will take an antacid, which is actually on the basic side. Many of the common household items we use for cleaning are on the basic end of the pH scale, such as oven cleaner, chlorine bleach, and drain cleaner. Anything on either end of the pH scale will be extremely caustic, as mentioned, and you should wear gloves when using these items. If you've ever had a chemical relaxer, you have had a chemical on the basic end of this pH scale added to your scalp. Chemical relaxers break down the bonds in the protein molecules of your hair. This allows the hair to be pulled straight. Once the hair has been pulled straight, you must apply a neutralizer in order to stop the chemical reaction going on in your hair. Otherwise, your hair would fall out. Buffers. A buffer is a type of molecule that helps a solution maintain constant pH. Buffers accept or release hydrogens in response to a pH change. The bicarbonate buffer found in our bloodstream helps to keep our pH within normal ranges. If you were doing a chemical reaction in a lab and you needed the pH to stay constant, you could use a buffer to help the pH stay constant. Let us review. Remember to write down the letter that corresponds to the correct answer to each question. Question 10. Which of the following has a basic pH? Choose the correct answer. Which of the following pH values represents the strongest acid? Choose the correct answer. This concludes our narrated PowerPoint lectures for Chapter 2. The next set of narrated lectures for this module will cover Chapter 3, Biological Molecules.